Hello friends, welcome to Knowledge Galaxy to rediscover the basics with Mayank Tiwari. My dear friends, with this video I expect minimum 10 new channel subscribers which believe in me and like my content. So before starting, please don't forget to like, share and subscribe to my channel. This will help me and encourage me to do further even better. So a premier coaching and training channel dedicated to metallurgy studies and consultancy, established to cater the needs of students, degree, diploma and AIM metallurgy, competitive and recruitment exams for GATE, SAIL and various other government and private sector companies, metallurgical industries and whosoever seeking knowledge and information about various subjects and topics of metallurgy, operational process optimization, productivity improvement analysis, concepts like 5S, total productive maintenance, TPM, quality circle, QC, root cause analysis, RCA, ISO systems, QMS, EMS and OSHAS, practical and effective communication English, written and spoken. My dear friends, to impart practical industrial knowledge as per your specific requirements via tailor-made training sessions for your colleagues, employees and students, please contact me on knowledgegalaxy26 @gmail.com or WhatsApp me on +919907144101 for scheduling and organizing the sessions at your place or via video conferencing. My dear friends, today in this video I am going to discuss about the various mechanical equipments of ferroalloy furnaces. These equipments are more or less common in all ferroalloy furnaces. So this will be very much helpful for you to know about this. So please let us start. The mechanical equipments of ferroalloy furnaces comprises of the following mechanisms: electrode holder, its suspension, slipping and positioning mechanism and electrode winch, furnace cooling system, burden conveying systems, fan ventilation and electrical tapping apparatus. My dear friends, in this present video I will be discussing and describing about the electrode holder, its suspension, slipping and positioning mechanisms, and other parts will be described in separate videos. So let's start again. Two types of electrode holders are used in ferroalloy furnaces. First, freely suspended, and second, rigidly connected to a mobile carriage or arm. First, furnaces with freely suspended electrode holders. Furnaces equipped with suspension type electrode holders are widely employed. Such electrode holders are installed on all large ore smelting furnaces as well as on some refining furnaces. The most important assembly unit in an electrode holder is the clamp. It is meant to hold the electrode in a definite position and to ensure perfect electrical contact between the clamps and the electrode. The electrode clamps operate in high temperature conditions and consequently should be provided with a reliable water cooling system. This system should be sufficiently rigid and whenever possible made of heat resisting materials. Until recently, the ring clamps consisting of a ring clamping screws with nuts and contact clamps were used. Contact clamps are cast of copper or copper alloys like bronze. These alloys are distinguished by low resistivity and satisfactory heat conduction, which makes for their reliable functioning. Satisfactory operating results are obtained with contact clamps made of chromous copper. Clamps may be hollow or with a cast-in steel, preferably cover tube for water cooling. Contact clamps are rectangular in shape with a rounded lower edge. Clamps made of copper water-cooled pipings have shown good operating results. Current density in the contact clamps usually averages 1.4 to 1.7 amperes per square centimeter. To prevent current leakage between the clamps and the ring, that is very important from the point of view of operational reliability. The clamp and the pressure screws are insulated with asbestos or mechanize, which are inserted into a special clamp housing at the point where the clamps are contacts the clamping screws or the thrust block. Insulation is protected by a steel plating inserted between it and the screws. Current to the contact clamps is supplied by copper pipes 70 mm in diameter. Clamps are suspended from the electrode shell by insulated lashings which ensure the flow of electric currents only from the clamps to the electrodes. The ring is composed of two halves interconnected by two steel pins through bronze sleeves. The use of half rings precludes a continuous magnetic circuit which is formed by the currents flowing through the electrodes. It is advisable to manufacture the rings out of non-magnetic heat resisting alloys which eliminate electric power losses on ring mechanizing as well as the need for water cooling. Half rings are hollow welded or cast steel castings with pockets containing specially shaped clamping nuts. The number of clamping screws corresponds to that of the clamps 6 to 8 in large furnaces. Nuts are made of cast iron or better still of bronze. The recesses on the outside of the ring follows the shape of the nut. The nut inserted into the recesses is rotated 90 degrees, then immobilized by two stop pins. The latter prevent it from rotating, while the flange of the recesses prevents it from falling out. The pins are consolidated by a plate inserted into guides welded to the upper surface of the ring. The nut is inserted and extracted together with the screw, as it is often impossible in emergencies to unscrew the nuts quickly. Clamping screws are loosened on the outside of the ring, 2 or 3 screws when it is necessary to slip the electrode. The screws are loosened and tightened without laying the furnace down. Wrenches should be well insulated, while workers slipping the electrodes should position themselves on non-conducting supports. A number of electrode holders equipped with remote control slipping mechanisms have been designed to facilitate the slipping of electrodes, as the work with long and unwieldy socket wrenches is exhausting. A hydraulic clamp is used in some designs. Pressure in the system in this case equals 25 to 30 kg per square centimeter. The clamping device drives the clamp close to the electrodes. When an electrode is to be slipped, pressure in the system should be removed and the clamping device then release the clamp. A number of designs of spring-type clamping devices have been designed. In this device, the pressure on the clamp exerted by two springs is adjusted by regulating screws. Electrode slipping in furnace equipped with A spring clamping device requires only repositioning of the limiting blocks and loosening of the friction grip of the braking mechanism. This greatly reduces the time and labor necessary for the electrode slipping operation. Practice has shown that spring clamps are absolutely reliable. Spring clamps permit electrode slipping without power input limitations. A perfect clamp electrode contact is ensured on the clamps thanks to even and constant spring pressure. This prolongs the service life of the clamps and drastically reduces their burnout failures. In a freely suspended electrode holder, the weight of the electrode acts on the electrode shell made of 8 to 10 mm sheet steel, which envelops the entire length of the electrode. The electrode shell dia is 100 to 150 mm larger than that of the electrode. The clearance between the shell and the electrode serves as a channel for the air delivered into the cylinder by a blower. The air is directed down to the clamps. The upper end of the electrode shell is provided with an asbestos or rubber gasket. Fan air is fed to a wind box welded onto a gasket through a gopher hose. A furnace can't be operated long without the electrodes being air-cooled, which makes it necessary to install a spare of blower for a group of furnaces. Individual blowers installed on the upper end of the electrode shell may also be used for the air cooling of the electrodes. Thus, the electrode shell solves simultaneously a number of problems like suspension of electrodes, second, their protection from heat radiation and furnace top gases, and third, cooling of electrodes for anode paste conditioning. The air fanning of the electrodes protects their surface above the clamps from dust, thus ensuring reliable contact between the clamps and the electrodes. It should be pointed out that in winter, warm air sometimes has to be fed into the shell as electrode baking temperature conditions are disturbed by cold air and the electrode paste is insufficiently heated. The result is that the electrode baking process becomes abnormal, reducing the mechanical strength of the baked electrode and worsening electrode duty because of higher oxidizing reactivity. In certain cases, a hollow water-cooled box shields of the electrode shell consisting of 4 to 8 sections made of 3 to 4 mm sheet steel is fastened onto the lower end of the electrode shell to improve the electrode performance. The clamps and the ring of the electrode holder are fastened through insulated supports to a ring provided at the lower end of the electrode shell. Water-cooled crossbars carrying mobile sleeper blocks and copper water-cooled conducting tubes are secured to the center of the electrode shell. In suspension-type electrode holders, the framework made of channels and possessing two vertical uprights is welded to the upper end of the electrode shell. The uprights are topped by a pulley casing. Steel cables are reeved in the pulleys and wound on the winch drum of the hoisting mechanism located on the electrode platform. One end of each cable is fixed to the winch frame, the other is secured to the winch drum. The drum is driven by a motor and a self-locking transmission gear. The pulley casing is insulated from the uprights, as the uprights, the frame and the shell are usually under voltage. The mechanism for feeding the electrode shell is shown in the next slide. You can pause the video and watch it properly. Let me explain it again here. It consists of a motor A, worm transmission gear B, two pairs of spur gears C and D, and two drums E. This is the diagram which I had just mentioned. Rating of motors varies with the presence or absence of the counterweight. Made of massive iron plates, it balances the weight of the electrode and the electrode holder. The speed of electrode travel is 0.3 to 0.6 meters per minute. Each winch is provided with a safety catch to limit hoisting or lowering. Compact gear winches or hydraulic devices are being extensively used of late as drives for electrode feeding mechanisms. Electrode slipping devices for furnaces with freely suspended electrode holders. Now I am going to discuss about this. The electrode should be slipped as it is consumed, that is, its working end should be enlarged. The electrode is slipped by means of a special braking device while the furnace power is on. A self-braking electrode of an ore smelting furnace is suspended from two steel bonds, one as shown in the next slide, welded to the electrode shell 6 as shown in the figure in the next slide. This is the schematic representation of braking system of a slipping of electrodes. Each band is reeved through two iron blocks 5 to provide friction and through friction grip 3 actuated by wheel 4. Band 2 is reeled on an iron rod resting on two brackets. The band is chosen of a size capable of withstanding the weight of the electrode. As the electrode is gradually fed down, the band is welded to the shell. In working position, the device is locked and the electrode travels together with the electrode holder. The electrode slipping operation is performed as follows. First, limiting blocks number 7 are moved to the distance of electrode slipping, that is approximately 100 to 250 mm above the locking grip. Both grips are loosened simultaneously by rotating the wheels, and the electrode sinks by gravity when the electrode holder is equipped with spring locking mechanism. When the electrodes are locked by setting screws, the latter are loosened with socket wrenches and are retightened when the operation is over. As soon as the electrodes have been slipped, friction grips are tightened with the aid of the above mentioned wheels. A new spring pneumatic device intended to mechanize the above operation have been designed. Its main elements are two grip rings, upper and lower, which lock and slip the electrode by means of compressed air fed to and evacuated from rubber cylinders. The lower grip is secured to the electrode shell while the upper one is stationary. The movement of the upper grip is ensured by hydraulic jacks or springs. When an electrode is to be slipped, air is let out of the cylinders, lower grips and jacks pressure is removed, after which the electrode sinks by gravity. The lower grip is then locked and the upper one is freed. The latter is lifted by means of jacks or springs and is again locked. The chief advantage of this design is the possibility of the remote controlling of the electrode slipping procedure and the absence of bands welded to the electrode shell, thus ensuring a smooth surface for the electrode and a more reliable contact between the clamps and the electrode. My dear friends, let us now discuss about furnaces with electrode holder rigidly connected to a mobile carriage. Electrode holders of this type are used in refining furnaces. They may be divided into several types like tong, chain or ring. A tong type electrode grip used for an electrode of 300 mm diameter is shown in the next slide. This is the electrode holder of the tong type for a 300 mm electrode. The electrode grip is provided with two contact clamps 1 and 2 with conducting bushings 5 and water cooling system 6, articulated joint 3 and coupling screws 4. My dear friends, these numbers are the part numbers which are mentioned and described in the picture. The grip is tightened or loosened by a coupling screw. An electrode grip of the chain type is shown in the next slide. This is chain type electrode holder for a 400 mm electrode. The electrode grip is provided with 4 clamps interconnected by articulated joints and braced together by a screw. The provision of 4 clamps increases their surface of contact with the electrode. The spring pneumatic grip is shown in the next slide. This is the spring pneumatic clamp for a 300 mm electrode. The electrode is locked by clamps 1 secured to ring 2 and clamps 3 fastened to stem 4. Clamping is brought about by stem 4 and springs 5, while declamping is effected by lever 6 with pneumatic drive. Number 7. When compressed air is fed into the pneumatic drive cylinder, the piston actuates stem 8, lever 6 moving leftwise, pulls stem 4, thus compressing the spring 5 and freeing the electrode. The clamps are suspended from the ring secured to an angled bracket by means of bolts. Since the mechanism operates in high temperature conditions, the electrode clamps are water cooled. Current is fed through pipes number 9, which simultaneously serve as water ducts. When the furnace is operated with graphitized electrodes, it is of prime importance to shorten the length of the working end of the electrodes to avoid breakage. The spring pneumatic grip for these electrodes were designed at Chelyabinsk Ferroalloys smelter, Russia. There are two types of travel mechanisms of bracket type electrodes: a stationary upright with a mobile carriage, and second, a mobile upright connected to carriage telescopic upright as shown in the next slide. In mechanism with a mobile carriage, figure A, the horizontal arm supporting the electrode grip is connected to the carriage moving on the wheels along with the stationary upright. This is the diagram of electrode positioning mechanisms, arm type. The stationary uprights, more often than not, are columns of a rectangular cross sections with counterweights located inside. The uprights are braced into a single framework. In mechanism with a telescopic upright, figure B, the horizontal arm is rigidly connected to the upright which moves along with the arm. In this case, the mobile upright moves on the guiding rollers installed in the stationary upright. The latter are secured to the furnace shell. In both cases, the horizontal arm is either a thick steel tube reinforced by stiffening ribs or a welded box-like water-cooled beam. A furnace equipped with telescopic electrode holders is smaller than that equipped with mobile carriage electrode holders. Moreover, electrode holders with telescopic uprights ensure better water cooling of the arm, rapid adjustment of electrode circle diameter, and allow the use of simple designs for the mechanized slipping of electrodes. The electric hoisting mechanism, however, is more massive and requires a more powerful electric motor. Electrode carriages or mobile uprights are actuated by electric or hydraulic drives. The motors of electrode hoisting mechanisms are installed behind the uprights or on the upper furnace platform. They are equipped with counterweights to reduce power consumption. The drives should be of a closed type dust-proof body. Electrode travel speed is 0.7 meters per minute. Carriage travel is adjusted by extreme position catches. My dear friends, here I raised my voice for this video. I hope you liked the content and found the video worth. So please don't forget to like, share and subscribe the channel. My dear friends, when you are receiving this much knowledge free of cost, so I expect that you must subscribe to my channel and share it with your friends. Do visit my channel repeatedly and regularly to watch all my videos, and also remember to press the bell icon so that you can get the notification of the new videos promptly. My dear friends, thank you very much for watching this video and see you in the next video. Do visit my channels repeatedly and regularly. I request you to all of you. Thank you very much again. See you soon in the next video.